All right, today we're going to look at something called parametric equations. So imagine that some kind of particle here is moving along this graph of curve C here. So you can see indicated by those arrows that it's moving this way along the curve. Uh, what we're saying here is that it would be impossible to describe this graph C by function y or f of x because this is not in fact a function. It fails our vertical line test to see if something's a function or not. You can see this intersects way more than one time, so it's not a function. Well, if we can't describe it as a function, then how would we graph it, or how would we work with it? So what we're going to do in order to be able to work with a function like this is suppose that both x and y are functions of another type of variable. In this case, we're going to call it t, and usually t is used because it becomes a function of time. That this is a new parameter. So we get two functions here, x being a function of time and y also being a function of time. And because we introduce this new parameter, these are called parametric equations. So each value of t determines some point xy, which we can then plot in the coordinate plane. As t varies, your xy points also vary, and it traces out a curve C, which we call a parametric curve. This parameter t does not necessarily represent time. So it can be something else, but oftentimes it is time. So we would define each point here, x, y, as a function of t in both instances. Notice that when you do this, you do also get a direction that these move. So parametrics, not only will it plot out points, but it also has a direction that these points are moving.